Hi, hello. In this video, I'll be showing you how to run a synthesis. I'm going to start with a very basic naive way of forcing constants, and then I'm going to build up how to run the same using a small tickle script. And then we're going to see how to do the same thing using a test bench. So I'm going to show you 3 ways of doing the simulation. Okay, so this is a project that I have created. It's a very simple project of AND gate. It just has 2 inputs, A and B, and C is the output, and its functionality is the output is AND of the 2 input bits A and B. So the first way of simulating would be to just come here and come to the left side in the simulation tab, click on run simulation, run behavioral simulation. It's gonna pop up a simulation window. Yep, these things take time, so please be patient. Right, so now it has shown up the digital file or the unit that it has simulated, which is the AND gate. And in this AND gate, there are 3 components, or rather objects. One is the input A, input B, and output C. You can see their values are U, which stands for uninitialized or undefined. So let's go ahead and initialize them. I'm just restarting it. Force constant, 1 value. Okay, force constant, value 1. Now I'm gonna run for 40 nanoseconds. You can see now A value is 1, B value is 1, and output C is value 1 again. If I have to change the value A again, I simply go do the same step. Force constant, value 0. Okay, and run again. See, now the value. So in the first 40 nanoseconds, we had A value is 1, and then after I forced it again to 0, so the output is forced again to 0. Same for, let's do the same again for force constant, put it 1 again. Okay, and then for another 49 seconds. You see the value A is back to 1, B is 1, and the output C is back to 1. Please observe that you have 0 nanosecond delays because this is a behavioral simulation. Okay, another way of forcing something that is repeating, for example, here in this, the signal A is being repeated after every 40 nanoseconds. The way it could be done is force clock. Basically, any signal that keeps repeating from, say, leading edge of 1 to trailing of 0 for every, say, 40 nanoseconds or 20 nanoseconds with a duty cycle of 50. So make it okay, and then run again. So now A value is toggling from 0 to 1 with a clock period of 20 nanoseconds. It just keeps repeating itself. You can keep running, and that keeps repeating. Okay, so this is a very naive way of running the simulation. You can keep forcing the constants or forcing clock and keep doing this. What it actually does in the backdrop is it actually runs these commands, these tickle commands, in the background. Right, when you're clicking and forcing constant, this is what is being fed to the engine. So what you could do is, I'm just gonna copy this. You could simply copy these commands and put it in a tickle file. For example, let's say start a file in the project directory, new file, text document, call it simulation.tickle. Yes. Restart. Okay, move for 40 seconds, then make this value 0. You can see this is the command when I initialized A as a clock. There is keeps repeating itself. Okay. Run for 100 nanoseconds. So I save this file, simulation.tickle, in this work area. What I'm going to do is, what you could do is the source, source, this file location. Let's see the file location. Properties, copy the location. Chaining slashes. Okay. Simulation.tickle. Sorry. I see it just redid the same thing again. Let me show you. Restart. So there's nothing. I'm just gonna source this. I see. So one way is to force the constants to this GUI, or the other way is to have those same commands written in a tickle file and source that command. This could be very useful when basically you're trying to run the same simulation over and over again on the same design and you're trying to debug. It would be very inconvenient if every time I want to simulate I have to do this right click, force constant and stuff like that. So it's a lot more cleaner to have something written in the file like this and then source. Okay, now I'm going to show you a lot more elegant way of doing it. It's called through the test bench. For this what we're going to do is go to the simulation sources, add source, add or create simulation sources. Next, you're gonna create file. Let's call it test and okay, finish. It's gonna ask for any ports. This is a test bench, it does not have any input or output ports. So yes, say yes. And now it's gonna give you a template of the test bench that you have asked for. Test end. Let's minimize this and focus. Okay. Okay, so this is your test bench. We keep the entity empty because it has no input or output. The first step that we're going to do is basically add a component. That is being tested, which is our AND gate. The way to add component is similar to the DD declaration. The only difference is that instead of entity, you're going to call it component. Okay, we're going to remove this case, and instead of end AND gate, it's end component. Okay. Second step is signal declaration of all inputs and output of the component. So you have signal A, comma B, comma C. I'm using the same name here, but you don't have to use the same name. It's just for better understanding. So you have the signal declaration done. So now let's begin the architecture. First thing in the architecture is to instantiate the component that is being tested. Component under test. So let's call it under test. That's the component name. Oh, sorry, that's the instant name, and next comes the component name, which is AND gate. And port map. You're gonna map these signals to the input and output of the component. We use the same names so that it's easier to understand. Signal A is mapped to port A of the component. Signal B is mapped to port B of the component. Signal C is mapped to port C of the component. Okay. Done that. Now let's insert the stimulus. Stimulus is your simulation pattern. Okay, so this happens in a process. Let's call it stim proc process. Okay, begin process and then end process. So in this, we're gonna wait for 100 nanoseconds. Why are we gonna wait? Because this FPGAs basically take at least 100 nanoseconds to basically initialize their values. So it's a good practice to basically wait for 100 nanoseconds before you apply your inputs and check your outputs. So we wait for the 100 nanoseconds. Then we're gonna start inserting our stimulus, which is, let's say A gets value logical 1, B gets value logical 1, then wait for say 20 nanoseconds, and then you can keep repeating this. B gets 0, A gets 0. So these are, you can there are only 2 bits here, and so I put all the patterns here, but you could if it's an STD logic vector, so you can keep on changing whatever patterns you want, and you can just go on and on. You could even give a for loop kind of thing and write this stimulus here. Please remember, this is a process, so it's going to keep repeating itself. Once it reaches the end here, it's gonna go back here again. So for it to wait or not repeat itself, I'm gonna put an indefinite wait statement so that the simulation comes down till here and then kind of stops. Okay, so we are done. We've saved this one. Now you can see, once you save this, in the simulation you have test and under test and you have this instantiation of the AND gate. The instant name is under test and the component name is AND gate. So so this is a wrapper under which you have this component and you're testing this component. Okay, to run simulation, you just select this in the simulation sources and then go run behavioral sources, run behavioral simulation. Now this is gonna pop up the similar simulation window. The only thing is that now you don't have to do the right click, left clicks, force any constant. It it's just gonna pick the stimulus that you have input it in the test and it's gonna apply it to the component and give its output. So you can see, let me just minimize this one so you could see. Right, so till 100 nanoseconds we wait, we don't apply any inputs. After 100 nanoseconds, you see we applied different patterns of A and B, and you can see the value C changes accordingly. Yeah, so this is the short tutorial for the simulation. I'll be providing these files also so that you could refer them and use them. Thank you.